Hi, we're not going to waste the time of having me on the big screen and then the little screen. We're just going to start with these from now on. So area of a quadrilateral. Um, through showing a couple of examples, I'm going to teach you about area of a quadrilateral. Now you already know about quadrilateral. You already know about finding the area of a square, for example, or a kite, or a rhombus, or a parallelogram. All those things are fine because you can deal with having two dimensions that are right angles to each other. But what if you're given a shape like this, with this being 80 degrees, this being 10.1, a distance of 10.1, this being 12.5, this distance also being 12.5, and an angle here to this cross cut as being 75 degrees. Okay, so when you're finding out the areas of quadrilaterals, the way you're going to go about this is you're going to make a diagonal cut from one vertex to another to create two or more triangles. Well, two triangles for quadrilaterals, but for five-sided figures, maybe three triangles, or for six-sided figures, maybe four triangles. So let's take a look at how to do this. Let's call this triangle A and this triangle B. So triangle A has two sides with an included angle, so that we can use our area formula. Area equals 1/2 of 10.1 times 12.5 times sine of 80 degrees. And therefore, A comes out to be 62.17. There's no units of measure here, but it would be square units, right? Units squared. All right. Now, triangle B has this side defined and an angle, but we don't have this side. Let's call this side D. So D isn't ready for us. We could find area B using 1/2 of 12.5 times this unknown side D. We don't have that yet, times sine of 75. But we don't have D yet. So how do we get D? We go back to triangle A, the first triangle, and we're going to use law of cosines because we have side, angle, side. So D squared is going to equal 10.1 squared plus 12.5 minus 2 times 12.5 squared times 2 times 10.1 times 12.5 times cosine of 80 degrees. All right, that same triangle again. And D winds up equaling 14.64. Now that 14.64 here has to go in here, 14.64. That's this. This side here is 14.64. I don't know if you can tell the pink from the orange. And then we wind up with area B winds up being 88.68 units squared. And then we add those two together. We add these two numbers together to get our total area of 150.85 units squared. And that's our area of the entire shape. Okay, we'll do this in another example in a minute.